Hello. With Unit 3, we are starting with 3.1, which is Introduction to Functions. So the first thing we have is what is a function? A function is going to be a relationship between two variables and with this, for every value of the first, there is only one corresponding value for the second. And we'll talk about what that means here in this first example. So example 1, determine if the following relations are functions. So in this example, we have two variables. We have a y and we have an x. We're going to, in this case, look at the x is our first variable, the y is the second. Alphabetically, x comes before y, which is why we're using the x first. So now we want to think about, okay, if we put values in for x, so I'm just going to do a little bit of side work here. So we'll say if x equals, we'll say a 1. What would our y be? Right, y would be 2. What if we let x be equal to 5? What would y be? Right, 10. You can see that no matter what value you'd put in for x, you will only ever get one value of y back. So therefore, this would be a function. So we'd say, yes, it is a function because for every value of x, there is only one y. So now let's think of example 1b. Volume is equal to the edge cubed, meaning the edge size cubed. I want you to pause the video, think about this. If you need to approach it, pick out some ideas here and see what you think about this one. Okay, good. So you'll notice for this one that we'd say, yes, this is also a function. Yes, because for every edge length, there is only one volume. Meaning, if you substitute a value in for the length of an edge of a cube, so let's say a cube has an edge length of 5 centimeters, the volume would be 5 times 5 times 5, which would be 125. Whereas if the edge was only 3, that would be 3 times 3 times 3, which would be 27. You can never get the same volume with different lengths of edges. Now, the next thing we're talking about is what we call functional notation. We say something is written in functional notation if they have this notation f of x, and that's how we're going to read it, f of x. So we might see a function that looks like f of x is equal to 2x, which you can notice that this is very similar to this example up here. The only difference is instead of writing a y, we wrote a f of x. That's because f of x has the same meaning as a y. So this would be the same thing as y equals 2 of x. Just we call this form functional notation. Sometimes we'll see numbers instead of the x. For example, we might see something like f of 3. Just like I said there, is read as, we'd call this f of 3. So we're saying what is the value of f of x, or what's this value of y when the x is 3? So example 2 just says rewrite in functional notation. Well, just like we said y is the same thing as f of x equals 6x cubed minus 5x, and that would be functional notation. Okay, the next one we're going to do, example 3, we have a couple here, is going to be evaluating these functions. So the first one, we have the function f of x equals negative 3x squared minus 7. We want to find f of 3 and f of negative 2. So let's start with f of 3. So we want to find f of 3. So we need to take the 3 and substitute it in for all of the x's. So 3 squared minus 7. And then we work through this. How do we simplify this? Well, we have to do the exponents first. And we know 3 squared is 9, so we have negative 3 times 9 minus 7, which would be negative 27 minus 7, which would be a negative 34. So we could say that f of 3 is equal to a negative 34. Now how that corresponds to graphs that we're going to be looking at in a couple units is we could take this and build a coordinate. We know that this was an x value, this is producing our y. So we could create the ordered pair 3 comma negative 34, which means if we were to be graphing this function in our calculator, this point would be a point on that graph. Okay, let's look at another example of this one. So I'm going to just put a vertical line here. So now we want to find f at negative 2 when we have negative 3 times negative 2 squared minus 7. Again, we want to simplify the negative 2 squared first. So we have negative 3. Negative 2 times negative 2 is a positive 4, and then subtract 7. Now we have negative 12 minus 7, which would give us a negative 19. So again, we could say f at negative 2 equals a negative 19. This would be our final answer. If we wanted to write it as a coordinate, and the instructions would tell us if we needed to, we'd write negative 2, comma, negative 19. Okay, why don't you pause the video and try letter B? Okay, so we have h of q equals 8 over q plus 2 times the square root of q. And we want to substitute a 4 for all of our q's, and then we're just evaluating. Again, we're not doing anything with the left. This is just a label. This is the name of the function, if you will. So we have 8 over 4 plus 2 times the square root of 4. Well, 8 over 4 is 2. Square root of 4 is 2. 2 times 2 is 4. 2 plus 4 is 6. So we have h of 4 equals 6. Okay, again, pause the video, try letter C. Okay, you can see I was running out of room for this one, but we get g of negative 1 equals negative 1. If you did not get this negative 1, make sure you go back and look at your work. Chances are the mistake lies in this first step. If we have negative 1 squared, keep in mind you have to put that in parentheses. So a negative 1 times a negative 1 is a positive 1. 2 times negative 1 is negative 2 plus 1. Negative 2 plus 1 is a negative 1. 1 divided by negative 1 is a negative 1. And that's how we get our answer. That's all we have for this section. If you have any questions, please reach out and let me know. Good luck with the homework.